Hey, welcome back to my channel. My name is Mark. I upload lectures and tutorial videos here in YouTube about anything related to the civil engineering curriculum. So this video is actually part 2 of a lecture series about time rates, and in this episode, we'll try to answer a new sample problem by applying the 3 simple easy steps that we have learned from the previous video. So for those of you who haven't watched it yet, you might want to watch it first before continuing on this one. So I will put the link on the description below. You can access it from there. And also, please don't forget to subscribe and hit the notification bell button below to help me grow this channel. And so, for today's video, we will answer sample problem number 2. A model 6 feet tall walks away from a lamppost 18 feet high at a rate of 2 feet per second. How fast does the end of her shadow move? So the problem has no given figure, so therefore we need to analyze, we need to internalize the problem. Okay, so according to the problem though, there is a model and there is a lamppost that casts shadow on the model as shown on this figure. The model is 6 feet tall while the lamppost is 18 feet high. And for this, for the sake of our solution, we will use x and s to denote these distances. Take note that x is the distance from the base of the lamppost to the model. And since according to the problem, the model is walking away from the lamppost, that means that your x is also changing through time. Because when the model moves away, your x, the distance from the model and the lamppost, is also increasing. So it is changing through time. And the rate at which x is changing with respect to time is actually the rate at which the model is walking away from the lamppost. So this means that this 2 feet per second here, this given 2 feet per second is actually the rate at which x is changing through time. Now, yung s naman, x is the distance from the lamppost to the tip of the shadow of the model. Now take note, when the model moves away from the lamppost, of course the tip of her shadow will also moves away from the lamppost. And therefore, the distance between the lamppost and the tip of the model will also change. So that means that s is also a variable. And the rate at which s is changing through time is actually what is asked in the problem, because it says there, how fast does the end of her shadow move? So now, we clearly now define what is asked in the problem. So we are trying to find for the value of the ds over dt, the rate at which s is changing through time. So that is what is asked in the problem. So to answer this problem, of course, we will follow the same steps. Okay, we have step number 1, and that is to find the equation that relates x and s. So, bakit x and s yung i-relate natin? Because first, yung x is given. The rate at which x is changing through time is given, and that is 2 feet per second. And s naman, s is what we are looking for in the problem, the rate at which s is changing through time. So we have to find an equation that relate x and s. So how do we do that? Okay, based on this figure, um, just by looking at the figure, we can see that there are 2 similar triangles that can be formed here, this one and this one. Okay, so if we take away those figures like this one, okay, so you can see that there are 2 similar triangles. And because of that, we can apply the property of similar triangle. We can apply the ratio and proportion. So we will apply that. Now take note that this distance, this distance right here, that is actually s minus x. Okay, and so by applying the ratio and proportion, we can say that this distance, this one, this s minus x, over this distance is equal to this distance over this distance. Okay? So, parang using this triangle lang muna, yung maliit na triangle, this distance daw over this distance is equal to yung malaki naman na triangle, this distance over this distance. Yeah, so we'll be using the ratio and proportion. Okay, so we can say we have s minus x over 6. So this is s minus x over 6. And that is equal to s over 18. So we have s over 18. So we were just using the ratio and proportion since we have here a similar triangle. Okay, now Next naman is we have to cross multiply. We'll multiply 18 here and we will multiply 6 here. So we'll have this equation. We have 18s minus 18x is equal to 6s. Next is we will combine similar terms. So we have to transpose 6s to the left side of the equation and the 18x naman to the right side of the equation. So we'll have this one. Yan. And simplifying, we will combine similar terms. Then we'll have 12s is equal to 18x. And so this is the answer for step number 1. Now, step number 2, we have to differentiate with respect to time. So we'll get the equation we found in step number 1 and we will differentiate it with respect to time like this. And so differentiating both sides of the equation, we'll have 12 ds over dt is equal to 18 dx over dt. So this is our final answer for step number 2 because your task is only to differentiate the equation with respect to time, and we'll stop at that. Now we'll go to step number 3, that is to answer what is asked in the problem. Now, kanina pa lang, we already defined what is asked in the problem. The problem is asking for the rate at which s is changing through time. So we'll be solving for ds over dt. So technically, we'll be solving for this one right here. We'll be solving for ds over dt. So to do that, we need to manipulate the equation. We have to rewrite the equation in terms of ds over dt. So we will divide both sides of the equation by 12 and then we'll get ds over dt is equal to 18 over 12 multiplied by dx over dt. But 18 over 12 can further be simplified and we'll have 3 over 2 multiplied by dx over dt. And that is ds over dt. And in order for you to get the numerical value for ds over dt, of course, you need first to find what is dx over dt. And again, as I have mentioned earlier, that dx over dt, that is the rate at which x is changing through time. And that is equal to the rate at which the model is moving away from the lamppost. And that is equal to 2 feet per second. Now, substituting this value to our equation, we'll get ds over dt equal to 3 feet per second. So this is our final answer for step number 3. So again, these are the steps in solving time rates. So we have find the equation, step number 1. Step number 2, we have to differentiate it with respect to time. And step number 3, answer what is asked on the problem. Now, how about if we change the question on the problem? So how about if the problem says, how fast does the shadow lengthen? So kanina, the problem is asking how fast does the tip of the shadow is moving. So the tip of the shadow is moving. Now, the problem is asking how fast does the shadow lengthen. Okay, let us try to analyze this one. So let us bring back again the model and the lamppost. So we have it here. Okay, let us try to understand what is asked in the problem. So how fast does the shadow lengthen? Now in this figure, take note that in this figure, the length of the shadow is this one. Okay? So instead of S denoting the distance from the lamppost to the tip of the shadow, let's denote S as the length of the shadow. Now take note that when the model moves away from the lamppost, of course, the length of her shadow will also increases in length. So that means that your S here is also changing through time. And the rate at which S is changing through time is what is asked on the problem. So ini. So we are looking actually for ds over dt. Now take note that S now, that is the length of the shadow as compared to the previous problem where the S is denoted as the distance from the lamppost to the tip of the shadow. Now this time S is the length of the shadow. So we are looking for ds over dt. Of course, we will apply the same steps. And step number 1, that is to find for the equation. So again, we are seeing here two similar triangles. We have this small triangle right here and the bigger triangle right here. So we can use the ratio and proportion. So we can say S is to 6. That's for the smaller triangle. And that is equal to x plus s. That's the distance. That is for the larger triangle. X plus s over 18. Yan. Okay, let me erase that one. Okay, so to answer step number 1, we'll use the ratio and proportion. So we have S over 6, this one, and this one. That is for the smaller triangle. That is equal to x plus s. X plus s is this distance. This is for the larger triangle. X plus s over 18. It's right here. So we have this equation na. Now, we'll just simplify this equation further. So what we need to do is to multiply a10 to s and 6 to s and x. So we will cross multiply them. So we'll get this equation. So we have 18s is equal to 6s plus 6x. Now, we will combine similar terms. So what we need to do is to transpose 6s to the right side of the equation, and then we'll have a10 minus 6s is equal to 6x. So this is our equation. Now, carrying out the operation, we have 18s minus 6s. We'll have 12s, then that is equal to 6x. Now, this is our answer for step number 1. Now, the next step is to differentiate the equation with respect to time. So we'll get that equation and we'll differentiate it with respect to time, and we'll have 12 multiplied by ds over dt is equal to 6 dx over dt. And so this is our answer for step number 2. Yan. So the last step is, of course, to answer what is asked in the problem. And the problem is asking for the value of the rate at which s is changing through time. That is the length of the shadow. So it says there, how fast does the length of the shadow, how fast does the shadow lengthen? So that is ds over dt. So we're looking for the value of ds over dt. ds over dt can be found on the equation found in step number 2. So we'll use that equation. Okay, and we will rewrite this equation in terms of ds over dt. So we'll have this one. We have ds over dt is equal to 6 over 12 multiplied by dx over dt. So we have just divide both sides of the equation by 12 to arrive at this equation. Simplifying further, this equation will be ds over dt equal to 1/2 dx over dt. And so this is our equation to solve ds over dt. But before you do that, you need first the value of dx over dt. And again, dx over dt, that is the rate at which this distance increases or decreases with respect to time. And that is equal to, in the given problem, equal to 2 feet per second. And so substituting that value to our equation, we'll get ds over dt equal to 1 feet per second. So this is our final answer for step number 3. So again, to conclude, the 3 simple easy steps in solving for problems related to time rates are this one. We have step number 1, you have to find for the equation. Step number 2, you have to differentiate the equation you have found with respect to time. And step number 3, of course, you have to answer what is asked on the problem. So those are the 3 simple easy steps we use in solving problems related to time rates. So the next video will try to answer this problem. Water is flowing into a vertical cylindrical tank at a rate of 18 cubic feet per minute. If the radius of the tank is 3 feet, how fast is the surface rising?